Okay, there we go. All right, so we are going to be talking about 5.1 angles of triangles. As I mentioned, our objective, okay, will be to classify triangles and apply the triangle sum theorem and the exterior angle theorem to solve for missing values. Okay, first let's go over our warm-up here. So your directions were to classify the triangles by their sides and their angles. Okay, so I asked you guys to think about the words isosceles, the words equilateral, and remember them, recall them from your middle school days. Okay. So over here, right, and then we had angles. So Michael mentioned obtuse angle, acute angle, right angle, right? So we want to make sure we pay attention to the types of angles that are in the triangles as well. So over here, for A, we see this 150-degree angle inside the triangle. Well, 150 degrees, that's an obtuse angle, which makes this actually an obtuse triangle. So one obtuse angle in the triangle automatically makes it an obtuse triangle. Okay, let me pick a better pen to write with here. Okay, and I'll come back to this one in a moment. Okay, if we take a look at B, based on the angles, we see here we have a right angle. Okay, so based on the angles, we see we have a right angle here. So this is automatically a right triangle, but it's more than a right triangle because we see these markings on the sides here. So they both have two little tick marks there, which means that these two sides are congruent to each other. Okay, which tells us this is actually more than just a right triangle. It is an isosceles right triangle because of these two congruent sides. Okay, so isosceles is based on the sides. The right is based on our right angle that we have right there. Okay, let's take a look at C. C here, if you'll notice right off the bat, again, we have these two congruent sides, right? And so this, we know this is going to be an isosceles once again. But is it an isosceles right, isosceles acute, or isosceles obtuse? So in this case, again, we see this 140-degree angle. Again, that's greater than 90 degrees. So this is an isosceles obtuse triangle. Okay. And then we come over here for D. Once again, we see two sides with the same number of markings. Okay. So if I had a third side, this would be equilateral, right? Because I would have three congruent sides, but I only have two congruent sides. So once again, this is isosceles. Now, as far as the angles go, we have these three angles. Are any of them obtuse or right? Okay, if we can see, each of these look to be less than 90 degrees. Okay, none of them look wide enough to be more than 90 degrees or a corner like this to look like 90 degrees. So they all three look to be acute, which would make them an isosceles acute triangle. Okay. So these are the classifications for all four of our triangles here. And so this is where our poll is going to come in. It's a very simple poll. I just kind of want to know where we're at here. Okay, so the question is, how many triangles did you classify correctly? And your options are all four, 3 out of 4, 2 out of 4, 1 out of 4, and none of them. Okay, remember that the poll is anonymous, so there is no shame in putting in the truth here. Okay, Okay, happy to see that quite a few people got at least half of them. Good, 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 good. I only have 15 out of 22 responses. I would like to get responses from everyone if possible. Okay, so please make sure that you are responding. I only have 17 out of 22, which means we have 5 people that have not voted yet. Okay, and I'm going to be closing this in 30 seconds. So if you would like to put in your vote, please make sure you do now. Okay, 6, 7, 8, 9, 30. End poll. Let's share the results. So it looks like 9 out of 18 of us had got at least 2 out of 4 of them. So we got half of them correct. That's good. I'm assuming it was the right triangle and maybe the obtuse triangles here. 3 out of 4 of us got 4, or I'm sorry, 4 out of 18 of us got 3 out of 4 correct. That's good. It's very good. 3 people got all 4 of them correct. Congratulations. And 2 people got none of them correct, which is okay because I'm asking you to remember things from a while ago, right? So good job on that, guys. Thank you for sharing. I appreciate it. And thank you for participating. I said I would come back to this, and there's a reason I wanted to come back to this, okay? So isosceles triangle, right, means 2 congruent sides. Equilateral triangle means 3 congruent sides in your triangle. But this one here doesn't have any congruent sides. Each of them, there's no congruent symbols there, right? We don't know that they're congruent. There is actually a word for this, and I didn't put it in because I didn't want you to mark it wrong in the poll, because it's not a common word that we know, or maybe you don't remember it. I'm sure you've heard about it when you did geometry in middle school, okay? But when you have no congruent sides, the word that represents no congruent sides is scalene. Okay? Scalene. That means no congruent sides in the triangle. Okay, I'm going to put it no congruent sides. Zoom in there so you guys can see that. So a scalene obtuse triangle is a triangle that has one obtuse angle, but no congruent sides. Okay? All right. Okay, so we got some more things to talk about here. Okay. Next, we want to identify specific angles in a triangle. Now, we have 2 theorems that we were going to talk about for this lesson. Okay, the first is the triangle sum theorem. Okay, and I normally do this lesson as one entire lesson. Okay, I normally do this lesson as one entire lesson. But part of me wants to split it into 2 days. We'll see how you guys do. Okay, we'll see how you guys do. So, but the first thing we need to talk about is we need to talk about exterior and interior angles. Okay, now interior angles, the word interior, right? That means inside. We should recognize that from our interior angles, like with lines cut by a transversal from our last two chapters, right? So the interior angles of a triangle are the angles that are inside our triangle at each corner here. Okay, notice that they are inside. Now, usually we pay attention to the interior angles of a triangle. There's nothing wrong with that. That's normally what we pay attention to, okay? The interior angles. Then we have our exterior angles, okay? Exterior angles, as you might remember, mean outside. They are on the exterior exit, right? But you're like, outside of what, Miss K? Well, outside the triangle, okay? So notice that if you take a triangle, and I'm going to show you guys how we got this, okay? If you take a triangle, any triangle really, okay? We have our, here, I actually want to do this. I'm going to do this in purple so we can see it, okay? And our interior angles are the angles created by the three sides of the triangle. So this angle right here is interior, this angle right here is interior, and this angle right here is interior. These are my three interior angles, okay? But a triangle also has exterior angles. So the way you get your exterior angles is if I were to take each one of these sides and extend them. So suppose I took this side here, and instead of stopping where they meet, I continued on this way. And then I can continue that pattern. So I then continue from this intersection and I come down this way and I continue on this way. Okay. And then I can take this and I continue on this way. What I have now created is I have created exterior angles. Okay. So this guy right here, this is an exterior angle to this interior angle. This angle here is the exterior angle to this interior angle. And then this angle here is the exterior angle to this interior angle. Okay, so each of these angles end up having an exterior angle at them. Okay, now you might be wondering, but Ms. K, how do you know which side and which direction to extend? Well, it really doesn't matter. Okay, it really doesn't matter, because if I were to extend it the opposite way, I would get vertical angles, right? So for example, if we take a look at this guy here, right? If this is the exterior angle, if I extended it here, actually I don't want to confuse you. That image is actually quite confusing. So let me bring that to the side over here. And I'm going to attempt to make the same triangle here. It's a good thing I'm a heavy drawer. That way I can see exactly what triangle I drew, okay? So in this triangle, I extended it this way, right? But what if I chose to extend it now this way, which means that I would come this way and I would extend it this way, and then continue on from here and extend it this way, okay? That's okay, because what ends up happening is I still get these exterior angles here. And these exterior angles are the same exact as their corresponding. So this exterior angle to this interior is the same thing as this exterior angle here. This one is the same as this one, and this one is the same as this one. Why? Because as I was saying, if I were to continue these guys this way, as I had done over here, I get vertical. And we all know that vertical angles are congruent. Okay. So depending on how you choose to extend your line, it's not a big deal. It doesn't matter which direction you extend it in. That's my point here. Okay. Because the exterior angle that gets created for that interior angle is going to be congruent. Okay. So on that note, okay, let's put some words down in our notes. It says an interior angle, okay. Now each pair of interior angles and exterior angles have a special relationship, okay. So I want you guys to take a look at this more basic image here, okay. If you take a look at each of these interior and exterior angles, there's a special relationship between them, because what if I did this? What does that look like right there? Okay, what are they creating? What are these two angles here creating? They're creating a straight line, right? And two angles that create a straight line are called what? Anyone remember? What kind of angle pair are they? Two angles that create a straight line.
External?
No, this is an external. This is an internal, right? So this is an exterior and this is an interior angle. Together, they are creating this straight line, right? So it's a combination, it's a pair of exterior angle and an interior angle. But think of them as just two angles that create a straight line. Do you guys remember the angle pair called a linear pair? Two angles that form a straight line. Okay. So each one of these interior and exterior angles are angles that are creating a straight line, right? They are a linear pair. So there's a beautiful relationship that happens with every interior and exterior angle, where that an interior angle and an exterior angle form a linear pair. And as Gabriel said in the chat, okay, they then add together to equal 180 degrees, aka therefore they are supplementary, which again means add together and set equal to 180 degrees. Okay. So that is one unique relationship about each interior and exterior angle pair. So each one of these guys here and here. So these two will add to equal 180. Okay. These two here will add to equal 180. And of course, these two here, interior and exterior, will add to equal 180. Okay. So this brings us to our first theorem. This actually is not a theorem. This is just a truth about interior and exterior angles. Okay. Our first theorem is the triangle sum theorem. And the triangle sum theorem says that the sum of the measures of the interior angles. So the triangle sum theorem is only about the interior angles of a triangle, okay? So the sum of the measures of the interior angles of a triangle is 180 degrees. Okay, the sum of the measures of the interior angles of a triangle is 180 degrees.
Is that any triangle?
Yep, that is any
Wow.
Euclidean triangle.
This is my favorite geometry theorem because it just applies to any triangle. The angles always add up to 180.
Yes,
The
they do.
interior angles.
Yes. The interior angles always add up to 180 degrees for any triangle. Okay, which means that if I take the measure of angle A here and I add it to the measure of angle B, and then I add that to the measure of angle C, these three angles added together will equal 180 degrees, or your measurements are wrong. Okay, so that means I can take this theorem and I can actually set up an equation, because if the sum of the interior angles is equal to 180 degrees, that means there's always an equation that can be set up where if I add the measure of all three angles of my triangle, it's going to equal 180 degrees. So I can take the measure of angle A plus the measure of angle B plus the measure of angle C and set it equal to 180 degrees, because the theorem tells me that that's always going to be the truth. Okay. So let's put that to the test. Let's try an example out here. Okay. So I have an example. It says solve for alpha. Okay, that looks like A. Actually, we'll call it A. It looks like A, so we're just going to call it A for the sake of not confusing people. Okay, so solve for A. And in this triangle, I don't know what kind of triangle it is. It looks like that's acute angle, that's an acute angle, and I have an A there. I want to find my third angle is labeled as A. It's the same thing as labeling it as X, right? It's a lowercase, so I know that it's not the name of this point. It's actually a variable, okay? Well, the triangle sum theorem tells me that if I add all three of these angles together, it's going to equal 180 degrees. So I'm going to be using my triangle sum theorem here. Okay, and again, my triangle sum theorem says that if I take this angle and add it to this angle, and then add it to this angle, it should equal 180 degrees. So I'm going to take this and I have A plus 24 degrees plus 72 degrees. That's three angles. First angle A, second angle 24 degrees, third angle 72 degrees. That's going to equal 180 degrees because this is a triangle and all three of these angles are the interior angles of the triangle. Okay. So then I just simplify. Okay, I do 24 plus 72. 24 plus 72 is 96. So this becomes A plus 96 degrees is equal to 180 degrees. And then I solve for A using algebra. So subtract 96 from both sides. Let me switch colors here. So subtract 96 degrees from both sides. Okay. That's going to leave me with A is equal to, these guys cancel because positive and negative. 180 degrees minus 96 degrees will be 84 degrees. And that's my missing angle right there. So A is equal to 84 degrees. That's it. Okay, that's all I got. That's all we needed. We need to solve for A. Okay. So any questions on that? Any clarification needed? What are your questions on this? What's something you need a clarification on? Do you need a clarification on how we set that up? Why we set up that equation? Do you need clarification on how we got 96 or how we got 84? Okay. So I want you guys to try this one. You try. Okay. Wait, hold on. I'm moving around. Sorry. I was having trouble moving around. So I want you guys to try this one. You try. Solve for the measure of angle 1. Okay. This 1 is not 1 degree. It's the name of the angle. Okay. This is not a number to be added to 38. So if that's going to confuse you, you can change this to A or X so that you don't confuse this as a number to add to 38. This is the name of the angle. Okay, it is the name of the angle. So if you want, you can change it to X, you can change it to A, you can change it to M, you can change it to a letter if you want, if that's going to confuse you. Okay. So I want you guys, I'm going to give you guys 30 seconds and I want you to try to set up the equation. But before you do, quick question. What's the measure of this angle right here? What's the measure of this angle right here? This little box. What does that indicate about this angle? Yes, good, good. Yes, it means that this angle right here is 90 degrees, right? That's a right angle. So you actually know the measure of this angle. It's 90 degrees because of that box. That's the symbol for a right angle. So you know this angle is 90 degrees. You know this angle is 38 degrees. You are trying to figure out the measure of angle 1. Okay. So 30 seconds, and I want you guys to try to set up that equation. And then we'll check in together. Okay, so let's quickly check here. Okay, so hopefully you are able to set up your equation as such. So measure of angle 1 plus 90 degrees plus 38 degrees is equal to 180 degrees. Is it okay if you don't have this in this exact order? Is it okay if you had 38 and then 90, or if you had the measure of angle 1 at the end, or any combination of order of these three? Does that matter? No, because it's all addition and they're all positive. Okay, so it does not matter what order is, as long as you are adding these three things and they equal 180 degrees. Okay. So then you solve. So I'm going to give you guys another minute to solve, just in case you need that 1 minute. Okay. All right. Almost there. Okay, if you're done, please write your answer privately to me in the chat. Are you waiting for people to write to me privately in the chat? Okay, Andres Moreno, great job. Gabriel, great job. Do I have any takers? Any other takers? Andres Leon, great job. Maya, great job. Andres, what do you mean by the wrong way? I'm curious to see what you mean by the wrong way, hun. Okay. That's actually not the wrong way. And I think you understand why that's not a wrong way of doing it, but I will try to explain it to you through the chat. Okay, I don't want to confuse the rest of the class. Okay. But let me quickly go over this here. So 90 plus 38 is actually going to be, we have measure of angle 1 plus 128 degrees is equal to 180 degrees. Subtract over the 128 degrees, we will be left with the measure of angle 1 is equal to 52 degrees. Okay. So actually, Andres Moreno had done it a little bit differently. He actually got 52 degrees by just doing 90 minus 38. Okay. Here's why it worked, Andres. If you take 180 degrees, your total for your triangle, and you subtract this 90 degrees from it, you're left with 90 degrees, right? So if you subtract your 90-degree angle, you're left with 90 degrees. That means angle 38, or this 38-degree angle and angle 1, they have to add up to the other 90 degrees that makes up the whole triangle. So by you doing 90 minus 38, you're really just saying, okay, since this angle is 90 degrees, right? That means the other two have to end up adding to 90 degrees so that all three total 180. It's the same thing as subtracting each angle individually, right? So you took 180, you subtracted the 90, and then you're left with 90, so you did 90 minus 38 degrees. Now, if these were different angles, it wouldn't have worked, right? Simply because you assumed that it was 90. But if you understand the idea of it, right, it's almost like just subtracting one angle at a time. Okay. Yes. Anders. Somewhat of a shortcut with the proper angles. Yes, absolutely. Okay. Now, what we can do is we can actually take this triangle sum theorem and we can extend it to algebra. Okay, so you remember me saying we're gonna actually do one theorem per day. So we're actually gonna spend 2 days on 5.1. Okay, so if you flip it over to examples 1, 2, and 3 at the top, okay, now we have X. And we're gonna be applying this to a bit of algebra, okay? So if we take a look here, actually all 3 of these are what kind of triangles here? What do these little boxes indicate? This is now the 4th time. It's the 4th time I'm asking you this question of what do these little boxes indicate? So at this time, if you haven't listened to the fact of what these little this box symbol indicates, then you are really trying not to learn. Okay. So what do these boxes indicate here? What are these? What's the measurement of each of these angles here? What's the measurement of that angle, and that angle? Thank you, Bernadette. Yes, absolutely. Thank you, Andres Moreno. I would like to hear from people that I have not heard from. So I'm going to call out a few people. I want to hear from you in the chat. I want to hear from Bethany. I want to hear from Denise. I want to hear from Heaven, Jasmine, Jayla, Joe. I want to hear from Jose, Joshua, Kebra, Leanne. I want to hear from Mariel. I want to hear from Michael. I want to hear from Paola, Samson, Ulysses, Zavon, and Kelly. Okay, I want to hear from you guys. Okay, what do these little boxes indicate here? Please type privately, guys. Okay, thank you, Mariel. Thank you, Paola. Thank you, Zavon. Thank you, Maya. Thank you, Paola. Thank you, Leanne. All right. Let's see here. All right, so yes, those of you that helped us out, they participated. These are 90-degree angles right there. Okay, so I'm gonna help you guys out with the first one. So we want to find the measure of each acute angle. Okay, so we're not just finding X. We then have to find the measure of each acute angle. Okay, so we got to pay attention here. So we're given expressions for these 2 angle measurements here. Notice you have the arrow inside and we have the degree symbol, which means this is an angle measurement. So this angle measurement is represented by 19x minus 1. This angle measurement is represented by 13x minus 5 right over here. Okay, so we have the first angle, second angle, third angle. Doesn't matter which one's first, second, or third. We just know we have 3 interior angles, which means if I have 3 interior angles or expressions for them, that means I can add them together and set them equal to the 180 degrees because of our triangle sum theorem. So that's exactly what I'm going to do. I'm going to take this guy, 19x minus 1. Okay. I'm going to add that to 13x minus 5. And so this is one angle. This is my second angle. Now here's my third angle plus 90. And that's going to equal 180 degrees because the sum of the 3 interior angles of a triangle equals 180 degrees. Okay, there's no, that doesn't change depending on if it's acute, obtuse, or a right triangle. It doesn't matter. Okay, the 3 interior angles of a triangle will always add together to equal 180 degrees. So then I start solving. I combine like terms. 13x plus, I'm sorry, 19x plus 13x. That gives me 32x. I have negative 1 minus 5 plus 90 degrees. So negative 1 minus 5 is negative 6. Plus 90 is going to be a positive 84. So I have plus 84 here. And bring down the equals 180. Subtract over my 84. Okay. So basic algebra here, guys. And I get 32x is equal to 180 minus 84 is 96. Okay. Divide by 32 to get my x by itself. Again, basic algebra. X is equal to 3. Okay. My directions are not find x. My directions are find the measure of each acute angle. So I need to then take this x and I need to plug it into here and here to find the measure of this acute angle and this acute angle. Okay, so I'm going to do that right up here. So 19x minus 1, 19x minus 1. Okay, I'm going to plug in my x here. My x is 3. I just found that. So 19 times 3 is 57. Minus 1 is 56. So this angle right here is 56 degrees. Okay. Do the same thing here for this guy. I'm going to use a different color here. 13 times my x minus 5. Again, I found my x to be 3, plugging that in. 13 times 3 is going to be 39. 39 minus 5 is 34. So this angle right here is 34 degrees. Okay. I can do a quick check. To see if my angles are correct, because what if I want to see if my x was correct, which means my angles would be correct, right? So I just add 56 plus 34 plus 90. If it equals 180, my x is correct, my angles are correct. If it doesn't equal 180, it's more or less. That means I need to go back and check my x, or maybe how I plugged it in, or when I simplified. So over here, let's see, I have 56 plus 34 plus 90. And that gives me 180 perfectly. I'm good to go. Okay. Any questions? Okay. I want you guys to set up number 2. Set up number 2. Okay. Okay. As you're working on setting up number 2, I'm going to put a poll up, okay? Just give me 30 seconds and I will make it happen. Okay. So here's your poll coming right your way. And I want you to select the correct way to set up the equation for this one using the triangle sum theorem. Okay, for number 2. Now, if you have things in a different order, that's okay.
Nice use of the polling feature. I hope that didn't take you too long to create. Very nice.
Thank you. I'm trying. Things like this, it's easy to try with. Some of the other ones are really difficult to do. Okay, we only have 12 out of 21. I would like to get a response from everyone, please. Response from everyone would be nice. At 13 out of 21. Okay, I am closing it off in 20 seconds. Closing it off in 20 seconds. If you are not participating, then you are hurting yourself. That's all I can say. All right, that's time. Okay, so let's see. We had 10 people say the third option was the correct setup. X plus 3x plus 2 plus 90 equals 180. We had 2 people say x plus 3x plus 2 equals 90 is also a correct setup. We have 1 person say x plus 3x plus 2 is equal to 180 is correct. Okay. The actual correct setup to be used with the triangle sum theorem is the third option. X for this angle right here, okay, plus 3x plus 2 for our second angle, plus 90, our third angle, is equal to 180 degrees. So first angle plus expression for second angle plus our third angle is equal to 180 degrees. That is the correct setup there, okay? Now, the 2 people that chose the top one, I hope it's because you subtracted the 90 from the 180 here and we're left with the 90 degrees, okay? I really hope that was the reason why you chose that. If it wasn't the reason why, then there's a misunderstanding there, okay? But as we solve this, I already have some kids sending me some of the answers. You guys are awesome. Okay, let's see what we're gonna have. Zavon, check your math. No, actually, Zavon, you're good. Never mind, I take that back. Denise, check your math. Okay. So let's see. So we have, this is X degrees, Andres. X degrees. Sorry, I didn't see your chat. Okay, so combining like terms here, I have X and 3X, and then I have 2 and 90. So it's going to be 4X plus 92 is equal to 180 degrees. Okay, so I'm going to then subtract over the 92. We'll get 4X is equal to 88. Okay, divide by 4, X will equal 22. Okay. So what does that leave me for my angles? Well, this angle is just X. It's X degrees, which means this angle is just simply 22 degrees, okay? And then this angle here, we actually do need to plug in for. So I have 3 times my X plus 2. My X is 22, so I'm going to plug that in here. So 3 times 22 plus 2 3 times 22 is 66, plus 2 is 68 degrees. So this angle right here is 68 degrees. Okay, quick check. My handy dandy calculator. Okay, I'm going to add my 3 angles together. 90 degrees, 68 degrees, 22 degrees. 98 plus 6, I'm sorry, not 98. Bleh. 90 plus 68 plus 22. We have 180 degrees, and we are good to go. Okay, there we go. There we go. There you go, number 2. Okay, so I want to give you guys time right now, and I want you to do number 3. I'm going to give you guys a total of 5 minutes. Okay, plenty of time. Set up, solve, give me the angles. Okay, give me the 2 acute angles there. You got 5 entire minutes, 5 of them. Okay. So I want you guys to go ahead and work on that. If you have questions or you want to confirm anything or anything of that nature, please don't hesitate to ask. Okay. I am here. Mr. L is here. All you got to do is say the word.
Bye, Ms. Carpathian.
Bye. Bye, Samson. All right. Okay, that was awesome. Bye, Callie. Bye, Heaven.